we are filling our vials and our test tubes with water. We have 3 different samples. I'd like to go over water quality testing and why we are doing water quality testing today. So the learning objectives, which you'll also see on your mats, is that you will be able to conduct water quality testing, which you'll do in just a moment. You will be able to analyze the data that you've collected, and you will be able to understand the importance of this water quality monitoring. So while you are filling up your pipette with your pipettes, I would like you guys to share a couple things about what you already know about water quality testing.
You use pH.
Okay, so pH is something that you might test. And Nathan, do you know much about what pH is?
It ranges to how basic or acidic a liquid is.
Okay, so how basic or acidic a liquid is. What are some other data points that we might want to collect for testing our drinking water?
The level of copper.
The level of copper.
The level of chlorine.
The level of chlorine. Harmony, do you have any ideas?
The level of nitrates.
Level of nitrates. Perfect. Okay. And so we've done a little bit of water quality testing already. When have we tested a bit of water? What might we have needed to test that's in this classroom already?
Fish tank.
Oh, the fish tank. Absolutely. And with the fish tank, there's an additional test that we do. It's the amount of salt dissolved in water. Does anyone remember what that is?
Salinity.
Salinity. Absolutely. All right. So, this on our field trip, we tested some water. We needed to test water quality. And we tested the pollutants that were in the water that can cause great harm. Water testing can help local facilities know how to treat our water. So even though, as Lauren stated earlier, we did some water quality testing on the Potomac River, we found that it was not great health. But the water that we drink still goes through a whole treatment process. In order to have that process go and deliver us water that we can feel comfortable and safe drinking, they need to have data. So this is why water quality testing is so important. The pollutants in the water that can cause great harm can be fixed through a process of aeration, coagulation, sedimentation, and filtration. And we're going to talk more about that in a moment. But the more immediate reason that we're testing this water is for our underwater grasses. All right, what do you all know about our underwater grasses? Nathan?
We have to have almost constant light on them, so they have some source of nutrients.
Absolutely. Does anyone know why we're growing these underwater grasses? We've only talked about this in one class, so I don't think we've talked about that in this class. Ms. Griffin?
I am guessing for the Chesapeake Bay.
Yes, eventually for the Chesapeake Bay. So we are currently growing underwater grasses, and this is what it looks like here, and it's in the back of our room. Underwater grasses are a wonderful biofiltering agent. Once they are big enough, we're going to take them and plant them in a tributary of the Chesapeake Bay, which is the Potomac River. They are just little teeny tiny ones now, but we are filling it with tap water. So we're going to be testing 3 sources of water today. Harmony and Victoria are testing the water from the underwater grasses. Ms. Griffin and Nathan are testing tap water, which is the water we're putting in there. And then Jamisha and Lauren are going to be testing the water from our fish tank. All right? And these are the tests that you're going to be studying today. We have dissolved oxygen, copper, nitrates, phosphates, hardness, chlorine, and pH. Are there any questions? All right, so let's get started. Yes, ma'am?
Are these filled up enough?
Yes, they look lovely. Actually, I think the chlorine should be a little bit more. Yeah, I would like a little bit more in those. Okay, these look great. The most important one is your dissolved oxygen needs to be filled as high as possible. So if your dissolved oxygen is ready and filled all the way up, I would like you to take your dissolved oxygen tablets, both of them, and you're going to drop it in the vial and cover it up. Before you drop your tablets in, This should be filled all the way to the top so that you can't possibly fit any more water in there at all.
But then we won't be able to close it.
It is okay if it spills. Thank you for that clarifying question. It is okay if it spills. Got it? Alright, the gloves are not as easy. Alright, while you are working on this, we're going to talk a little bit about the importance of dissolved oxygen. So natural waters are saturated with this type of oxygen. There are high levels of bacteria that can decrease these oxygen levels. Yes, I'll show you. Oh yes, you may begin shaking it back and forth.
Oh, do we have to shake it?
And you can go like this.
Up and down? or
Yep,
what?
and you're going to keep doing that until I tell you to stop.
Can you
Okay.
shake it myself?
You're going to shake it back and forth like this. Okay. So when there's bacteria and when there's a lot of decomposing matter, this absorbs oxygen in the river and it creates something called a dead zone. And the dead zone is what we're the most concerned with. And who might be most affected by a dead zone, Victoria?
Fish.
Fish, because fish and other animals need oxygen. Okay? And this dead zone's along the bottom. Can anyone think about what type of fish in particular might be hanging around the bottom? Nathan?
Catfish.
Catfish. So if you're like me and love some fried catfish sandwiches, this is definitely something that we're monitoring. And without catfish, we completely lose our biodiversity, which can cause greater problems in the ecosystem. All right, whoever is taking the oxygen back and forth, you can just go ahead and keep on doing that. All right, I will tell you when you can stop. The next thing I want to look at is copper.
Just so your computer.
Okay, the next thing I want to talk about is copper. Copper comes from leaching of the pipes, leaching from copper pipes or rock weathering. And there is corrosion of piping that can happen. And what this will do is the addition of copper salts are used to treat algae growth. All of this is in your packet. So we seem to have a smart board that is not being so smart today. So we can actually turn in our packets to the copper page and we'll be able to follow along. Okay? The main problem with copper is that the high doses of copper can lead to liver damage or anemia. Does anyone know what anemia is? What is anemia? That's sickle cell anemia. Absolutely, that's sickle cell anemia. Ms. Griffin?
We don't have enough iron in your blood for oxygen distribution during body.
You don't have enough iron in your blood for oxygen distribution. So the next thing we're going to do is copper. You can go ahead and drop your copper tablet right in your copper vial. And this is going to be read fairly instantly. And what you're going to look at is the test reagent combines with copper to produce a blue color. So if you're seeing a blue color,
Do we need to shake it?
we've got some copper. It should dissolve. Yep, you can shake it just to dissolve it. Gently mix it.
Can you use the pipette to mix?
No. Thank you for asking. Lauren asked if you can use the pipette to mix, and the answer is no. All right. So far we have tested dissolved oxygen. Have we analyzed dissolved oxygen yet? No. And we are testing copper, and we are analyzing copper right now. Okay, so those are two of our learning objectives. Is anyone seeing a change of color occur?
Ours is orange now.
Yours is not turning blue, so you're good. You guys are getting some copper. Yours is tap water.
Please excuse this interruption. Coach Alexander, please come to the activities office. Coach Russie Alexander, please come to the activities office.
Okay. Thank you, Ms. Griffin, for writing your answers down in your packet. This packet is important for me to know whether or not you are achieving mastery of this learning objective. So it is important that you go ahead and start writing, filling in your table. Okay, your table will be found on page 12. All right. So orange is fine, blue is copper. All right, we're moving on to nitrates. The those of you shaking, right here, so you guys are number 1, you guys are number 2, and you guys are number 3.
And if it changes from blue to orange, that's okay.
That's fine. Yeah. So what color? Yes, ma'am. Right here. Yeah, so you guys are, you're going to be collected water sample. You're number 3.
Did you write the color? Or
Yes, yes, please write the color. Thank you. Yep, so what color? It is now orange. All right. Those of you rotating the dissolved oxygen, you may put that down. And we are still waiting 5 minutes before analyzing it. Okay, but the rotation can stop.
I think it got cold.
It's okay. Totally okay. Totally fine. Nope, leave it blank and we'll share data at the end before, while we're analyzing it. All right. So we've done dissolved oxygen, where we have tested dissolved oxygen, waiting to analyze it. We have tested copper and we have analyzed it. Okay, we have our tap water seems to have reacted with copper. And yes. And ours over here, this is the fish tank, and then we're fine. Okay. And middle table, very little. So we're good with copper. Nitrates. Nitrates are the most common contaminant. So this is the most common that we need to look at. And nitrates come from seepage through rock. So we're talking about the source of our water, of our drinking water. This is where they become contaminated. This is where they become contaminated. So yeah, we're just doing nitrates right now. Oh, I can get one. Must have fallen on the way over. Here you are. Okay, we're welcome. So does anyone know any other sources that you might have from nitrates, or sources of nitrates?
Food.
Oxygen.
Or not oxygen.
Nitrates in the water. How might it get from the source water?
Oh.
It did dissolve really fast, yeah. But you still have to wait. It's going to take 5 minutes. So nitrates come from septic systems, fertilizer pollution, so agriculture, and organic wastes. What might be some agriculture? Like what are we talking about? Fertilizer, yes. The fertilizer that we use to grow the crops that we need are a contributor to nitrates in our drinking water. Do we need any help here?
We were just looking at what nitrates mean.
What's coming up? Okay, perfect. Thank you all for using your resources. All right, so we're going to go ahead and test nitrates. And nitrate also takes 5 minutes to develop. So you're going to put that there, and I will let you know when it's time for us to look at nitrates. It takes 5 more minutes. Nope, nothing yet. Thank you for your clarifying question. You're just going to leave it for now.
There's nothing more.
Okay. Phosphates. Phosphates is the next one. And phosphates is a nutrient, chemical. It's essential for life. All right, phosphates is not necessarily a bad thing, okay? However, it is a major source of fertilizer from industrial wastes, and too much can cause some significant problems. The main problem that phosphates can cause are algal blooms. Do you all see this picture here? This is a picture of a boy in China, and I got this picture from National Geographic. This is what an algal bloom looks like. This is not typical. They're not usually this big and this thick and luscious. But what do you think would be a significant problem with algal blooms?
Okay.
Victoria?
Light will get to the bottom. And
Light
then,
cannot get to the bottom, and then what?
The grasses and stuff can't grow.
Yeah, exactly. So the biofiltering, the underwater grasses can't grow. And then what happens when that underwater grass dies?
fish die.
Fish die.
Ecosystem dies.
CO2 and the decomposition that happens will lead to a dead zone.
Fish will
Okay.
get
So again, the dissolved oxygen help us detect if we're getting dead zones, and the phosphates help us detect if we can, in the future, start to have dead zones because of these algal blooms. Okay, do you see how
They're
these
pretty.
tests are starting? It does look pretty.
I think we have a question.
Yes, ma'am.
Do fish get like caught in it?
Yeah, it's not great for fish health either. It's not great for fish health. I'm sorry, Jamisha? Yep, go ahead and put it in, and then you're going to wait. I'll let you know when that's ready. All right.
Should we shake it?
Yes, you should gently shake it so it mixes, and then leave it. That would be perfect. All right, now we're going to look at hardness. Those of you in my Earth Space Science class, which I guess is pretty much everyone, when have we talked about hardness? What is a time that we've talked about hardness already?
We talk about the minerals
Minerals.
and their properties.
Absolutely, it's a property of minerals, okay? And does anyone remember the scale that it's measured on?
It's made by man.
Mohs. Mohs scale of hardness, very good, the Mohs scale of hardness. All right, so we are going to look at this in a very similar way, but the main thing that we want to find out is how hard our water is. Now this test should probably be the same for all three samples because ultimately both our underwater grasses and our fish tank, the water comes from our tap water, okay? I have not filtered any minerals out, so the hardness for all three of us should be the same. So this is caused by calcium and magnesium in the water, and it's found in over 80% of the United States. It causes scale deposits, and you guys can see a picture right here, what would be a significant problem. So if these were your pipes at home, what is going to be something that you're going to be concerned about, especially around the weather today?
Oh, they're
Are you
pretty.
ready? Yeah, so this is not enough room for flow, and you're going to definitely have problems. So another thing is that it does, it increases soap consumption. So ladies, if you live in an area that has hard water, which we do, you might notice that you have to use a lot more soap to get some of the minerals out. Okay?
Like when you're washing your hair,
Yeah.
you'll use more soap with hard water, and then like the alternative is soft water. So if you went, like you might go to like a friend's house in another city and take a shower and just realize like, oh, I just use like, my hair is like super, super soapy with just a little bit amount.
Oh.
So like, you use different amounts of soap depending on like what kind of water you have. And you don't usually notice it, so you go to someone else's house and you're like, oh.
Yeah.
And they have healthier.
What's that, Victoria?
Their hair is like way healthier because their water.
In
is
soft water?
Yeah.
Yeah, I mean, you're using less
Less
products, right?
yeah.
So we love shampoo and soap because it cleans our hair, but again, it's like more products that we're putting in our hair and where else?
The drain.
In the drain.
In our environment.
And in our environment, absolutely. And it also affects taste, right? Speaking of taste, chlorine. Chlorine is the next thing we're going to talk about. But before we move on to chlorine, I want to pause and take a look at our dissolved oxygen. Okay? I want to look at our dissolved oxygen. Now, Victoria and Harmony, the temperature of your water is 78 degrees. 78 degrees. In Celsius, you're going to need to take a look at that because you need to know the temperature of your water in order to figure out the dissolved oxygen. So in Celsius, your water is 25.5 degrees. 25.5 degrees. Okay? Your water is the exact same. Okay? Yours is also 78 degrees Fahrenheit or 25.5 degrees. Ms. Griffin and Nathan, your water is 23 degrees.
Where do we write these?
23 degrees. So you're going to turn to the chart. You're going to turn to the chart in your packet, which is on page, not easy what I love, 5. Thank you, Ms. Griffin. It is on page 5. And you need to look at your, you need to use your chart to figure out the temperature, to figure out the dissolved oxygen, and then you're going to convert it to percentage by using your chart. Yes, Lauren?
I forgot.
Okay. Sorry, I took too long to answer. Why might we need to know temperature? Why might we need to know temperature to understand percentage of dissolved oxygen? In what way would temperature affect dissolved gases?
The speed at which they move.
That's not what we're thinking about here. Have you ever had a soda and you open it up at room temperature and it just fizzes like crazy?
Yes.
Yeah? If you have a cold soda, you open it up, it does not fizz as much. Cold liquid can hold more dissolved gas than hot liquid. Okay? It's the opposite of dissolved solids.
So it's not because you shake it, it's because it's warm.
Correct. It's because it's warm.
Mind blown.
You got it now?
Wait, okay, I remember that.
Yes, ma'am.
Why do you need so much more water?
Because you want to fill it all the way so you have less air bubbles. See this? This is halfway filled with air. So Lauren's question is, why did we have to fill this vial all the way full for dissolved oxygen but not for the others? And that's because we don't want to have any air bubbles trapped in there. We want to know what gas is already in there. That's another reason I got the water samples as soon as we started the lesson, so that it wasn't just sitting there. Are there any other questions before we move on? Yes? Nope, you just figure out, so what number did you guys get for your dissolved oxygen? 0. Okay, so yours is 0. 0 is 0. Yeah. Yep. Yep, perfect. Okay. While we're talking about dissolved gases, this is a perfect time to move to chlorine. Now, Nathan, you might know this answer, and if you don't, I'm sorry I put you on the spot. But why do I fill up buckets of water and leave it open for 24 hours before adding it to the underwater grasses?
Leave it out.
Leave it completely exposed to the air. And anyone can answer this question if you have a guess.
What was the question again?
Why might I fill up buckets of tap water, I wait 24 hours, and then we fill it up into the underwater grasses? Why might I do that?
Chlorine evaporates.
Yes, so that the chlorine evaporates, okay? And it's not going to be perfect, and we're going to now test to see if we're leaving it out or not, because it's just that surface area of the bucket. But that's another reason that we're doing these water testings. That's the relevance of this test, is to make sure that we are not over-chlorinating our underwater grasses. Or the fish tank. Or the fish tank, absolutely. We don't have any life in the fish tank yet, so hopefully. But there is life, we have live rock, so we
A
definitely.
live rock?
No, not a live rock, we have live rock.
What does that mean?
So we have coral in there and rock that it's helping balance the tank before we have fish in there. It's valuable bacteria.
Why can't this
We could do that. I should do that soon. We'll get fish soon, promise. So chlorine is used to clean our drinking water. Okay, we put chlorine in a pool, but we also add chlorine to our drinking water. And we know that safe concentrations are between 0.1 and 0.4 parts per million. And this exists in its free state, or it combines with organic compounds. And organic compounds are particularly concerning because some of these can actually be carcinogens. Okay? And then activated charcoal can filter these out.
What are carcinogens again?
Does anyone know what carcinogens might be? No?
Gases.
Carcinogens are things that can possibly lead to cancer. Okay, and that's something we absolutely want to make sure is not in our drinking water. Thank you for that question, Ms. Griffin. All right, so without any further ado, let's add our chlorine tablets. Let's add our chlorine tablets. Yep. We just did our dissolved oxygen, so that's 0. And we're about to check back on our hardness and our phosphates. that we've added our hardness tablets, I would like you to go back to our phosphates, and we're going to see how that's been doing. Phosphate should be ready to check. All right? You're going to use your indicator on your table and just record your phosphate level. You're going to record your phosphate level. Okay? And we're looking for something around 1 or 2 would be best. Did anyone get phosphates higher than that?
Higher than what?
1 or 2. All right, we're good. You should be good for algal blooms. And if you look at our underwater fish tank, underwater grasses tank, you'll notice that we're actually doing pretty good with that. Okay, so that makes sense. We're seeing the evidence of that test.
Yeah,
Lastly,
they're excellent. Good.
very good. You're going to take your pH strip. You're going to dip it in the water for 2 seconds. And then you're going to compare it to your pH color chart at the bottom. Do not wait until it dries.
That looks like a 9.
Do not wait until it dries.
Yes.
I really like that partners are talking to each other and trying to figure out how things are. I agree. One thing, since we're done with our nitrates, that I want to point out is look at the difference in our nitrate levels here. Here's your nitrates. Okay.
That's
yours
good
is
though.
yours is better than ours, and this is the tap water.
All right. So this is the saltwater fish tank, which has had the live rock, and also what else does this one have that these don't? Salt. This is a much higher salinity level. Okay. And how is our pH levels?
6, 7.
6, 7. All right. 6 is not great. Who has 6? All right. So that's actually good. 6 is actually good for what we're doing here. Everything else should be 7. I would say 7 is probably closer to what we want. So anything less than 7 is acidic. Anything greater than 7 is alkalinic. And pH can be low pH can be caused by industrial waste, contaminations. Sodium carbonate or sodium hydroxide can help to raise it. It's a water conditioner. And acidic waters are corrosive or staining. Okay, so that's the main issue that we have there. All right, our learning objectives, just to recap. We were to conduct water quality testing. Did we do that?
Yep.
Yes. Did we learn to analyze the data collected?
Yes.
Yes, we did. We compared it to these colors, and we talked about, are these good levels or are these bad levels? And we understand the importance of water quality monitoring. Victoria, why is it important to monitor water quality?
Because it's important for human health and for our environment.
It's important for human health and for our environment. Absolutely correct. Does anyone else want to add reasons that water quality testing are important? Nailed it. All right. Excellent. So that I can make sure that we all have achieved mastery on this learning objective, not just the ones that have answered questions, please complete your packets, and I'd be happy to help you with that. And then we will have an exit slip after this before you go. All right. Thank you very much.